Welcome back. So today I'm going to be continuing to work on Script. So the last I think it was a stream, if I'm not mistaken. I was working on I can open it up here. I was working on some stuff with constants, right? I was trying to get constants to work, and I did actually encounter an issue. Right, as I was refactoring some stuff with structures, I figured out that if you reassign them, right, it didn't work like this before, so I did actually mess something up. If you reassign them like this, then it's gonna cause a stack overflow. So, or stack underflow rather. So it tries to grab something that doesn't exist. So obviously that is an issue, right? So I'd like to be able to reassign it. So I need to figure out what exactly it is. It has something to do with grabbing the variable, I'm assuming. So I'll look into that. It might be right. So I'll need to look into variable reassignment. So that's the plan for today. And then once that's ready, then we'll be ready to try to introduce C structs, right? So it's going to be the same structs, but when you pass them to a C function, like if I open up this, right? So if you say you want right, so this last one here is the color. Say you want to pass this struct color there, then it's going to generate this same structure in C code because it corresponds pretty much directly to C, right? The types that we have, right? It's very easily transferable to C. So even if you have like other structures, that point to other ones, you can have all that, right? So we can have that, and then we just have to have a way to differentiate between pointers to structures and then and the structures themselves. We might be able to just use pointer, but then the type checking might get a little messed up, right? Anyway, that's gonna be for later, so that shouldn't be too difficult to do. I'll probably stream that because it'll be a bigger endeavor, right? So I'm gonna go to just the back end here, and I'm going to do var reassign, I think is where it's gonna be, right? So when we reassign the variables, I'm thinking, right, am I trying to read it? I don't know, it's hard to tell. Maybe I will actually use GDB and take a look. Main, that's not right. Select main. Nope, that I cannot type at all. /main. There we go. Pre-enable, and we'll break on run instructions, and we'll see what the instructions are. It's not too complicated, so it should be fairly easy. So we'll just run that with test.data. Let's actually print the instruction counts, So let's see. Print machine.program size. That's the count of instructions. So there's only 29. That's not too much. So we're pushing stuff. So let's actually open the code. Side by side, maybe, perhaps even. You can go like this. Go into build. That's not Kano. So we have this, right? The structures. I don't think those should be used. So it should just be with this. So we're pushing something. We're pushing a value. Machine.instruction. I'll even display this. Display machine.instructions. Data ID. And that'll display what we have here. So this is we're pushing 1. So that might be the size. Oh, okay. It's probably the size of this, right? Because we're allocating size for the structure, and this is only 1 byte. So that would actually make sense. I wonder if that has something to do with it. Okay, let's see. So if we go here, then we have an alloc, right? So we're allocating. We are allocating. It's kind of hard to see over here, and I'm not sure how to adjust the size of the... That does not do it. What the heck? I messed something up very badly. Oh, okay, I just swapped them. Okay, yeah, I did not realize. Okay, I'm not super familiar with Tmods, but, let's see. So I can't really see what this is saying. Oh, I can do this. Okay. So we're getting the value, basically. And the value, is what we popped off. So I can print value. So that's 1. That's just basically we're allocating it. So there's no problems there, as far as I'm aware. Then we're duplicating it. Now this, I don't think that was not where, the underflow was, so we're good there. We're pushing a value. What is this value going to be? Int type 0. Why is it? Oh, okay, because we're just allocating it up front, so it's going to allocate it at 0. Okay. Maybe we're actually grabbing the variable. I don't know. It's hard to tell, right? Casted point pointer. Okay, so I guess we're writing to it. That's what it is. Yeah, we're writing at the 0th position. Okay, that makes sense, because it's the first element, so we add 0 to it. Which that is something that can be optimized out once I get to optimizations, right? Now this is quite interesting. That's 15. So that's the value that we're writing to it. So that makes sense. That makes good sense to me. Right. So we write to it. Pop up the pointer, and we're good. And let me print machine dot stack size. It's currently 1. Okay. So we're duplicating a value. And what is it that we are grabbing exactly? Stack size minus 1. So that'd be 0. So that's still within bounds. So now you print A. And that's going to be... I'm assuming this is a pointer, actually. Yeah, it is a pointer. It says pointer. Okay, I can read. Okay, so we're duplicating that. Yeah, okay, so we duplicate the pointer so we can write it, basically. And we're pushing... What is this value? Int type... 0. Ooh, okay, because we're allocating for this, I'm assuming. Okay, that might be an issue. We're trying to allocate that. I'm not sure. Right, because that's basically going to allocate a new struct and then assign this one. So we want to actually deallocate the old one. So that's something that we should keep in mind, right? If it's a struct that we're reassigning to, we need to do that. So yeah, we need to think about that, right? Adding to it. Okay, and we go here to void pointer. And now we're pushing 12. Okay, so we're pushing 12, and that's what we're going to write to the thing. And then we're pushing 0, that's the index, right? Or maybe it's 8. Why is it 8? Oh, shoot, that could be... Why would it be 8? What? Okay, hang on. And the next thing, we have the size. Yeah, see, so that shouldn't be... Oh, shoot, because it doesn't interpret this as that. So we're writing out of bounds here. So that's not quite good. That is not quite good. Data, and that is 12. So that needs to be 1. So that's invalid. We don't really have a way of knowing that because, that is interesting. Yes, we're gonna write to it, and that's gonna cause an issue. Like it's writing out of bounds, basically. Unallocated area. So I need to think about how to fix that. That is... Okay, stack size, and then we're grabbing the thing, right? And we subtract from it. So print machine.stack size is 3. Okay. What is IP currently? 19. Okay, so we're getting there. So we're swapping. So I'm assuming this is where it's probably going to come. So we pop off the machine. Print index. Print machine.stack size. So index is 0. That is 1. And we swap stack size minus index. Print index dot word dot is 0. That is correct. Alright, so that was not where the issue came. Alright, let's keep going. Pop. Okay. Machine.stack size. That's 1, so pop is fine. But then we push again. Okay. And this is pushing 255. Why is that? Why is that? Right, so I don't really know what's going on anymore. What the heck? It's an int type with value of 255. That is... Wait, here. As int. Where is as? Okay, it's -1. Yeah, why do we have a -1? That's not right. They were trying to indupe with that. Print index is -1. Okay, and that is where stack underflow comes from. So, yeah, I'm not sure where that -1 came from. That is interesting. Is it something new here? Maybe I'll print the index. Index is, I guess, just an integer. Index. So let's print it out each time, and we can sort of take a look at what we've got here. 1. Okay, so that's not it. It is not from the index. Not from the index. Okay, but it could be, because it is a global variable, so that actually makes sense. Let's print it out and call it again, because it's just temporary, so value.var.name global. So let's print that out. Is it global? Build. That's not what I wanted to print. Let's print that. So we have, let's look at the stack size. Is that going to be 2? Is that what it is? Is that where the issue is coming? It's size type, that's fine. 1. Okay, so that should be 1. Because 1, yeah, so that'd be minus index, which is going to be 0, right? Oh, shoot, but then we generate a pop, right? We gen a pop here. But we're just swapping them, so that's not actually... That's just swapping it with the 0's position, so that is fine. Okay. JK. Gen pop. So, yeah, that should be fine, because we're just swapping them, and then we're popping the top one off. So I don't think that's the issue exactly. Let's see. So we somehow get a -1, right? And I'm not sure exactly where. We will break on generate, and we'll run test.kano. Yes. And I'm just going to kind of see what we have here. So gen programs, that's what we want to be. We're into gen bar, so let's actually. Oh, let's run that again. Hang on. So I want to go to. Let's actually. Well, yeah. We disable. We enable, and then it'll be, and running again. Yes. Okay. Gen program. There we go. So now we're in there. We are in. So var reassign. So the first thing we have is a var reassign. Oh, because we generated the variables, so this is the reassignment. Okay, so this might be where the issue comes in, right? Let's print node value.var.value.data 0. Let's print that. Yeah, dot value. Dot value. Yeah, I'm not sure what it. Well, it should be as like a. I'm not sure. Let's just keep going here. So print indexing, and it's not -1, it is 1. Variable get variable. So we get that. And it is global, so we do call this one. So let me step into this, and perhaps that's not what I wanted. Let's continue. Okay, we can't continue, and now let's start over. Okay, step in here, and we'll go back here. Right, it's one ahead of where we're at. So it's actually on Gen Expert right now. So index. And not. Okay. That's weird. I don't know. Let's break on Gen Global. Gen Global var. No. In swap. Okay. Gen Global in swap. I don't know what type. Gen Global in swap. That's not what it is. So Gen Global in swap. Doesn't recognize. Okay, there we go. Next. So now we should be in there. Should be in. What the heck happened? So printing stuff out. Okay, is it actually okay? It's printing stuff out. Scan. That is string. Let's maybe let's do that. GPD.in enable break on. Let's just do gen okay, right? And run test.kano. And let's see. It's going. Okay. And we have this. So I want no, I think I just missed it. Yeah, okay, let me start it. I want to go to this one, step into that. And let's see, so we get the variable. That's not really the one that I'm interested in. And now, okay. So here, I want to exit this one, and I didn't want to do that. So, right, I want to step into the one that is called here. Alright, gen global in swap. So that's what I wanted. So, gen stack size. So that basically gets the stack size. And then we push a value. So what is the value? The value is 1. That is fine. Gen sub. And we subtract the stack size from the sub. So that's fine. Because that we were pushing 1 was the issue, right? No, actually we popped it off, didn't we? So maybe we should look at what the stack size returns. Because that could be an issue. No doubt. Let's look at that. So let's break on run instructions now. Let's go here. Let's go to the actual one that we're looking at, right? So it started with a. What's the first one that it calls actually? Gen expert. So we generate the expression. And then get the so we gen global in swap. So it's going to be a stack size, I guess, is where we will wait for. So we'll wait for it to be inst stack size. Machine.instructions.data IP and not type. So we'll just display the type for now. Unless it says inst stack size, so SS. Then we are interested, right? Let's keep going. Stack size, and I missed it. Okay. And let's print machine.stack stack size -1, and that is 1. Okay, and then we push 1, right? Print machine.instruction.data IP dot let's do that. P, and that is 1. So we push 1 and we have 1. So then we subtract that and we're fine. We are golden. Machine.stack size -1. Is that? That is not right. Because you have a pointer there. Stack, machine.stack machine. Well, okay, can I do like that 1? Machine.stack at 0. Does that print out the first one? Like, I can't really. Machine.stack size -1. And that is int type, and that's 0. Okay, so that is 0. So that is what is expected here, right? So I think this one actually worked. But then there was another one that did not. Right, because this first one, is that for this? In swap. So the index is there, and then we're fine there. Right, so that's actually fine. Let's go here. So we're popping something. Pushing, and what is the value? Let's actually just display the value as well. Display machine.instructions.data IP dot, what is it, just value? Dot value. And then we can see, sort of what the value is here. And the value is -1. Okay, so right after that, we had a few things, and then we had a push -1. So where does that come from? That is interesting. Okay, so it's a little after that to generate, right? Excuse me. Indupe, and that's when we get the underflow. So let's maybe start it all over. And let's go here and let's look at what's after the variable reassign. What's the next thing we don't need? Native. So we're calling native exit, right? So perhaps something in here is messed up. You know what? Is it because of this? That could make sense, right? Because we're trying to access this, but this was written too much, right? We're writing out of bounds. Could that be where the issue is? But it's a direct push. We're pushing -1 directly, so I don't know about that. Let's maybe go here. Step into this gen expression, which I'm not sure that's where it is even, because we didn't call the native yet. So step to that. Structure. X is that, right? But this isn't a direct push, right? We're not pushing the value directly here, so I don't know about that. Alright, let's go here and let's maybe even look at this one, gen vars, and see what we have here. So we generate a variable declaration, all that. Okay, that was it. So continue, run instruction, and let's go here again. So we're displaying it again, so that is good. So let's see, let's see where it is exactly, right? So we don't have the in swap. Let's stop at the stack size or in swap or whatever it is, right? Well, it's really stack size that it can be first. So this is gonna be almost at the end. Stack size. Okay, and print IP. That's gonna be 16. So IP is 16. We generate the stack size. So what else do we have, right? So what is the actual print machine.data? No, stack data size. What was it again? I don't remember. Program is 29. So we have quite a bit to go here. So let's see. We have gen global inswap, which contains what? So 1, 2, 3, 4 instructions, I would see. And then after that, we generate a pop. So 5 instructions total. So that'd be 5 more. That'd be 21. And then we have, yeah, so that's not, well, okay, but we have the stuff after the expression is generated first. So perhaps this is for, like, a different one, right? Instructions.data. Right. So instead of IP, let's look at 28. Yes, that's the last one. 26. Data 25. Right, so this is the in swap, right? Two. Alright, maybe not. So, so we get like extra stuff. Where does that come from? Right, so this in swap is the end here. Right, so the one right after that is going to be the in swap. Instruction data 19. So that's what we're on currently, right? Or well, we're on the stack size currently, but in swap, then that. So that's 20. So why is there all this other stuff here as well? Does the gen expression generate more stuff? Let's see. So this native exit, that's where we're at. We generate this one thing, and then dang, I'm a little confused here. Let's run it again. Yes. Step into here, and do I have state dot program? Do I have that? And state dot machine. Yeah. Okay. Print state dot machine dot program size is currently 0. Do not like append it to that. Dot machine dot no. Program size. It's still 0, so that's interesting. At 0. Okay. Let's go to the end here and go to the next one and take a look at this, right? Because this should be the end of it. The end of it. So, expert field. So we generate all of that. Oh shoot, but I guess the field offset generates a lot of stuff. So let's step into there. And where could the negative one come from? What is stack size? And then let's print okay, stack size 0. So that's where struct bar dot stack position. Okay. Interesting. Is this an invalid struct? Hang on. So here, step into this, right? And let's print the structure. So it is foo, right? It says that. Is it incorrect? Var name is X. Step into that, and then we have struct name and var. So we get the variable, print struct var is that, and then print structure is this, but then var, stack position is 1. Hang on. Stack compose. We subtract that from, right, so it's like, that's not good. So stack size 0, so I made an oopsie. Okay, so I think it does go back to this, right? Go back to the reassign. So something wrong is here, right? So we generate the in swap. Something to do with generating the expression, right? And then the stack size is going to be messed up there. And then we pop it off and it becomes 0. But we still have something on the stack. So I think it's like not accounted for properly. Let's go back here. So that's where the negative one is coming from. That was a little bit throwing me off, but I see how it came to be that now. Let me print state.stack size. State.stack size. Okay, 1 currently. Generate the expression. State.stack size is 1 again. Why is it 1 after generating the expression? Okay. That is not good, so it should have gone up there. Let's step into that, right, and see sort of what we get here. So, expert struct. So this... Right, okay, because it's based on the structure. Wait, what? We don't allocate the structure here. So we're modifying the existing one, but then we pop it off. We really want to allocate a new one. I'm not sure. Right. Let's go right here. And let me just do this really quick. So if node dot value dot var dot is struct, I think it's called. And let's do not that. Then we want to gen pop. Right. Let me just see that. Right. Because then I wouldn't pop it off, and we'd be writing directly to that one. I need to do that. Just make sure it's all good. Okay. Back info still. Okay. Break on gen program. Right. Kano. Yes. Let's see. So where do we print state stack size and print node.value.r dot struct false, but it is a struct. What? Oh shoot, because it's already assigned. So we need to get the variable. So let's get the variable. You know what? We could even do this, right? So let's do variable equals get variable. That's the state and node value.var.name, right? And then we could do, so make sure. Int index equals var dot var dot what? Stack position, I think. And then here we could do if var.global, and do that. And then if var.instruct, if not, right? Something like that. And then you don't search for it twice anyway, so it's better anyway. Then it does do that. And it did, okay. So we still have the issue where it's writing too much, right? Because this is a U8. But it's writing 8 bytes, so we're, running out of bounds, and that obviously causes some issues. But if I make this an int, which can be an int64 basically, then we don't have that issue, and it's still 12, so that is correct. So we can reassign it. We don't deallocate it. I'll worry about that later. Right, because really, right, we sort of want it to expand the base, since we are reassigning it. But I guess we don't reallocate it, do we? We just ran into it, so we don't even need to do that. So that was kind of weird. We reached out of memory, but it was soon enough that it was fine. Yeah, some memory issues that might occur, but overall, that does work. So let me try to commit that, and that might be about it, because that was really what I wanted to do. Fix issue with struct. Right, so I might want to make it allocate a new one, but really it is fine with just overwriting the old one, because it's the same thing, right? So we don't really need to, we just need to change the old one. Fix issue with struct, stack. It was an underflow, so I guess I can't actually read. Close number 9. We get to push. Yeah, maybe more issues will come up, but that was really the main one that I wanted to fix there, and it did. It did close it. Okay, good. So yeah, the other thing, I do have to do that testing thing. The other thing I was talking about was here, the C structs, right? So basically, I'll talk about how that'll work, sort of, and then I will, then I'm gonna end the video. So we have this, right? So like I was showing. Let me close this window because I don't need that. Like I was showing. So say we want this, draw text, and this is gonna be, actually, is that a color? Let's do a clear background, because that'd be easier. Color. We're gonna pass color in. Right now, it's not gonna work, right, because that's not actually supported. Yeah, expect that. But what we can do, we can support structs, that'll be pretty easy, in the parsing, right, we just have to update that. And then what we'll do is we'll generate C code, which is gonna basically generate typedef struct, color, and it's gonna make it, uint 8t, R, right? So it'll keep the same names and all that stuff. That's going to be super easy to do. Or at least it should be, famous last words, right? Right, so we can have that. Generate this. It'll probably call it native color, right? To not conflict with anything, because nothing's going to be called, native whatever. So it's like a namespace sort of thing. And then we'll generate that in there, and we'll cast it, right? So I'll probably have 2 different ways to do this. So we'll have, this, which means regular struct. And then something like that, or I'm not sure exactly, I'll think about it, to indicate a pointer to the struct. So we cast it to a pointer, right, in C, or it would have to cast it to a pointer and then dereference it because it is a pointer. When we pop it off the stack, it's a pointer to the struct. So we need to cast it to it. Since it's stored, should be stored more or less the same as you would. Ooh, I hope there isn't any issues with that, because there is padding that could cause some issues. in certain cases. So there might be some edge cases where other things may need to be done. So let me think about that. Right, if there's the padding, that could be problematic. Alternatively, we could just take all the values in the struct that we pop off and then redo it. But that's only if that happens, right? So if I encounter any particular case where it breaks, then I'll have to do that. But otherwise, it should be fine. This could be a U32 actually, clear background. Let's see, that I don't think is going to work. Expected token, yes. This cannot exist. Yeah, I think it's going to crash. Yeah, expected that, but found that, because it is not a U32 when we actually pass it here. So we can make it, right, because the struct literals, they have some issues, right? But with them, we could pass the color here. Color. That's the wrong one, actually. Okay, color, that is the clear background. BG color, right? We'll pass that, and we'll make it just 0. Constant 32 equals 0. Let's get those constants in there. Let's go. And there we go. It's the same color. It can be changed, right? It's not super great with how it works, but let's try 1, 2, 3. Right? I'm not sure how that works exactly, right? Okay, that made it really red. Yeah. So I kind of right. If we had these structures, obviously it would be quite a bit better. The way you could do it. I think there is a way to represent it in an integer, and if we had hex literals, I feel like that would make it easier as well, because there's certain ways you can represent it like that. But regardless, right? This basically is just a 32-bit integer because we have just 4 U8s here. But yeah. Anyways, so that does work, right? We can change it. We can get 7 even, something like that. I made it darker red. Okay. Right, so it's more there. So is it kind of like that? So 5, 6, 7, right? If we do 0, 0, 0, right, that's actually not going to be valid, is it? So it's be 100, that, 0, 0. Make it blue, okay. I'm not sure if this is how it works, right? But, yeah, I made it more blue. Yeah, I don't get how it works exactly. I'm not very good at colors, math, anything like that. I made it green, okay. I think that's something to do with that, right? But I don't think it's represented that same way in decimal, so it's kind of weird how it works. But that would be like that. Okay, yeah, that looks kind of okay. I'm gonna go back to 0 because that made it look all right. That's gonna make it 0, I think, as well, even though there's a bunch of Okay. Anyway, but yeah, we're getting there to being able to make a game, right? So we have that. That is a very important one because otherwise, the DLL block, that'll be useful as well for it'll be more optimized and faster, right? So we have that and that. And then this other one, it's not like a big deal to not have, but it would be helpful, and I'll probably implement it. But yeah, anyway, that's gonna be about it for today. It was a shorter video, but yeah, got it done. So that's gonna be about it. Thank you guys for watching, and I'll see you guys next time. Bye.